Alright, this is Comet 67P, and there's a lander on here, and it's taking these pictures, and it's up there right now, and it's collecting data on all kinds of things. Now, what I want you to look at is this structure right here, this circular structure, and these stripes, and these little fluting things in these stripes, you see them? The little lines that go inside those bigger stripes. Now, the structure here, I want you to look at these. See these? And that little, like a lips, it almost looks like in the middle. They're a little, almost they look like a set of lips now. That structure, I am saying, is biological, and I will show you why. Alright, let's look at the structure of Comet 67P. There's a ball on this end, and then a stalk that comes up, and then it flares out here. Now, let's see, you see, here's what it looks like. There's the ball, there's the stalk, and there's the flare. Now, you see these gas jets that are shooting out? They're shooting out like somebody shot them out of a can in here. That's not just blowing off the edge of it. These are being shot out of little vascular openings, which are literally burning dust. The gases of smoke of burning meat out of these little vessels, the blood vessels that are coming to service the ball, and they come up this way. And then there's other ones that are vascular entries that service the blood through everywhere. This was a biological system, and I'm going to prove it to you. There's almost no question whatsoever. And the gases that are given off are amines and polycyclic aromatic hydrocarbons, and that is considered carcinogenous by the CDC, or the Centers for Disease Control. It's indoor gases given off by cooking meats. They're amines, polycyclic aromatic hydrocarbons, and that is what's in space, and that's why the astronauts smell steak, because everything out there is meat. This is meat. This was meat, and it's now a chunk of a tendon in the ball, and I'm going to show you what a tendon is built like. Did you know that space smells like steak? The astronauts come back from spacewalks saying that their suits smell like steak. All right, you see what it says right up here? Scientists also found hypoxanthine and xanthine, two other chemicals used in biological processes and found in muscle tissues. All right, now, I always get asked, well, why should you speak to this? How come you're qualified to talk about the things you talk about? And they relate to my background in the semiconductor industry. Now, I was field engineering manager for a large electronics company, global electronics company, and I supervised the first release of electronic equipment in the United States, literally the first ones that came in the country, and I had to make sure that they worked when they hit the field. Now, and these are the different types of semiconductors. I'm just showing you this is because crystals are what everything is made of. You're nothing more than a bag full of crystals, surrounded with crystals. Everything that's consists of two atoms together minimum is a crystal. That's all there is to it, and everything virtually does consist that way, unless it's in a laboratory or it's like an inert gas or something. Anyway, here's the key to this whole thing. Solid materials are classified by the way the atoms are arranged. That's where I go, to the atoms, because that's my background now, is to crystalline structure of semiconductors. That's what makes them work. And in your cell phone, everything that you own that is electronic now works with semiconductors, and I'll talk about that in a minute. Anyway, they're all classified by the way the atoms are arranged within that solid. All right, remember that, the way their atoms are arranged. They're the same atoms in the same solid can be two different things. Carbon is in your pencil and it is in your diamond ring. Same exact identical elemental stuff, it's in different crystalline form. Now, Materials in which atoms are placed at random are called amorphous. They're just all floating around together like a bag full of sand. Materials in which atoms are placed in a highly ordered structure are called crystalline, and we all know what that is, crystals. All right. Now, then you go into polycrystalline materials, and materials with a high degree of short-range order and no long-range order. All right. Now, if you go into all this stuff, these Bravius lattices and all these different things, this is what creates the angularity in crystals. All right, that's why they have this formulas and all vectors and all this business. That doesn't mean anything. All you have to know is that crystals arrange themselves in molecules well, here, I'm going to show you something that I used to do. Now, I'm not showing this to brag, but this is what I used to do. This is the kind of stuff that I would work on to make sure that, the crystals were right, that they were doing, I just studied this kind of stuff. I didn't really actually need this for the stuff I was doing, but it related so deeply that I got so deep into it I couldn't stop. So that's just what it is. And I never did stop. And I found out that literally everything that's being taught about chemistry and geology and rocks and everything is just not correct. And I'm going to show you why I say that. And this is why I say I can speak to this. This is, and this book is not, this book is filled with this. It's not like one day I did this and that was the end of the day. And plus I have other books here full of formulas and things about different, heat reactions, and I'm pretty deep into this. So I think I can speak to this. I don't think anybody can speak against me about it, and I will speak to anybody about it. So that's what I'm just saying, and that's just the way it is. All right. Part of the things I had to do was to find out why things weren't working, and a lot of it had to do with electrostatic charges that were coming back from the Earth, and a lot of it had to do with the conditions that existed near the equipment that was being run, and a lot of it had to do with conditions that were inside of matter that had highly polar material like nylon and rayon and silk and things like that. And we found that operators sitting on nylon stools with silk underwear on literally were shocking the equipment and making them flip out, because these things run on 5 volts and you can get up to 50,000 volts sitting with leather shoes and so forth, and all these conditions had to exist. That's when they found out that they needed to use clamping and reactive capacitance, inductive capacitance, reactance. There's a whole series of things they did to prevent this, and it has to do with rare earth metals. And anyway, it goes deep into crystals, and crystals are the key to everything. Now, you see this? There's 5 different types of crystals. Now, here's what you got to understand. And the reason I'm telling you this is because this is why I show you things that are squared off, and how could that happen? It's natural. It's what happens when things petrify and crystallize. Now, you see everything here? 90 degrees, these kind of angles. This one here is anything that isn't 90 degrees and 120 degrees. There's it's the construction of lattice points and using vectors. I'm not going to bore you with all the little details, but what it boils down to is you have squares, rectangles, hexagons, and obliques, which are they just don't fit in these other categories. And these little things over here don't mean much. It just means that one side equals the other in a square, and 90 degrees is prevalent. And this rectangle, one side doesn't equal the other. As you know, rectangle's not square, and 90 degrees prevalent. Hexagon, 120 degrees prevalent, and one side equals the next equals the next. Oblique. Anyway, you see what's going on there. Now, these things don't, a bunch of stuff, but this is the key. This is what they form. Now, when crystals or metals are crystals, and then you got a lot of iron in your blood, and you've got all kinds of magnesium, you got all kinds of metals and things in your blood. And what happens is when you vaporize off all the rest of the stuff that's in the blood, and what's remainder in the little voids and things that are after the vaporization of the gooey stuff, literally vaporizes out, they call it sublimation, you end up with holes, and they get started to fill up with these little squares, and then another one will add, and another one will add, and sometimes they'll step off to the side. It's called twinning, and they have different characteristics, and some of them make spikes and all kinds of things, and that's what's happening. That's just that's how it works, and believe me, I know what I'm talking about. This is exactly how it works, and this is what causes these structures to be seen in these rocks. And that is what happened, is I started seeing them in the rocks, and I said, I know what's doing this, and then I found out what's doing it, and this is what's doing it. So, and I'm going to show you the things that I found, and I defy anyone, because I've had them DNA tested, their DNA, there's no question, and I've had them CAT scanned, and no question, they were alive, and Yale refuses to even discuss it, and Harvard, and they just says that I don't want to see them, but they're not real. Now, why is my DNA test not real? Nobody will discuss this with me, and when they find out that Harvard and Yale decided they're not real without ever looking at them and just arbitrarily deciding that DNA means nothing, they laugh at me. So everybody laughs at me, and I have the evidence, and I want it looked at. That's all I'm asking for. It makes sense to me. All right, these are just rocks out of your backyard, veins and arteries. And what you see, this little black dot right there? Hold them in a little closer on that. That black dot is the vein, and the reason the veins remain plugged up and have the black in them is because, and normally they do that, some of them bleed, which the other ones do. There's a vein right there, it still has the vein actually in it. But what happens is they seal off because there's a clamp, and the arteries remain open. But rocks have these. If you look at them up, look carefully. But some of them are huge, and you won't find them real easily. But almost all rocks have these things. Lava doesn't, but rocks were creatures at one time. They were body parts of creatures. This right here is an iron meteorite that came through and smelted as it entered our atmosphere and heated up. And it was a lung or a heart, but it had vascular entries. You see that red? You see that black? Here, I'm going to comb in a little closer. You see it? That red is the FeO3. That's the plus oxygen coming down to feed the body, the tissue. And then as it goes over here, it turns black, and by the time it gets to the vein, it's black as the ace of spades. It goes back up to get pumped again. And the reason this is cut and is an a meteorite, and literally there's DNA falling out of this. I guarantee you that if you tested that, you're going to find DNA. And the reason you're going to find DNA is because of chelation. And chelation takes metal complexes, which hemoglobin is heavily invested in with the iron, and these become chelated, which means they're surrounded by these little molecules they call ligands, and they protect them from being destroyed. And they can protect them for a very, very, very long time. And that we got DNA out of a lot, excuse me, out of 3 different mud fossils, which they're in all of them, literally, if you look for it. That's what that is, and that's what happens as they come through the. I've taken chondrite meteorites and looked at those. They all were biological entities. These weren't just rocks, and just the rocks that you see in your backyard aren't just rocks either. If you cut them in half, you're going to find veins and arteries. And these are the blood vessels that I'm talking about, and these are the tubular holes, and these little bumps, those are the vascular cellular network which is inside of veins and blood vessels. All right, this rock is not just a rock. If you look over here, these are bands of muscle, and that is not the product of sedimentation. These are bands of muscle, and they transition back to this area here, which is an area that is a goopy area, and then you have what they call the abrupt transition, and then you go back into the fibrous part of the tendon. Up here is what they call the, I believe it's called SLRP, small leucine-rich proteins. And you see this red, it's red slurpy blood, and that's what the layers of the tendons slide over. This is a tendon assembly, a muscle assembly, and that's how they slide. And somebody sent me this picture, whoops, of a huge rock. You see this hole right here? whoops, let me come back up here. You see this little hole in this one? Right over here? These are the areas of blood vessels. And somebody sent me a picture of this giant one, and somebody had poked the hole through that, and that's the blood vessel. And it just goes right through there. You can see daylight through that hole. But it's not hard to do because it's blood. The rest is got tissues through it, which are the tissues are collagen type 1, and they are the same thing that's in your bones, only they're made into laminates that are flexible, but they're heavily mineralized. And when you get into the straps of the tendons, they are extremely mineralized, and they are really limestone.